So we now get into the algebra. So how do we write expressions without absolute value? The problem is when we start putting an x in there, the absolute value works sometimes. Sometimes it does something. For example, when x is 0, we're going to take the absolute value of -4, and so that will change it. Other times, for other x's, we're not going to do anything. So when x is equal to +5, well, that's going to give us +1 inside the absolute value. Well, we don't change +1 when we apply absolute value. So it's going to behave differently depending on what x is. Okay, depending on, and what is really the boundary? The boundary is when, and I'm going to make this very clear. The boundary of when absolute value works and it doesn't work is at the inside equals 0. So inside equals 0. Okay, so that's where our boundary is going to be. So the boundary really for this one here is going to be at 4. So it's going to do something when it's bigger than 4. It's going to do something differently when it's less than 4, when the x value is less than 4. So how do I write this out then? Well, I need to do this as a piecewise function. So we have to split it into two pieces. So there's going to be a positive domain. Okay, so when the inside is positive, and there's going to be a negative domain where the inside is negative. Okay, and where's the boundary between positive and negative? The boundary is when it's equal to 0. So when it's equal to 0 is when x is equal to 4. If the inside is positive, what are the values of x that make the inside positive? Okay, so anything bigger than 4. And we're just going to include the equal to on the positive side. Now, if we think of the negative, if it's less than 4, okay, it's going to be negative. And we could put that equal to here. Okay, we can put it here, or we could put it on the bottom one. We could do that. Just as long as we don't put it on both. Okay, because we don't want to lose that equal to 4. Okay, so I'm just going to arbitrarily just leave it on there. So this is not a big deal. Just make sure that one of them has an equal. Okay, so back to the idea then. When the inside is positive is when x is greater than 4. It's going to behave differently. So how is it going to behave? Well, it's going to be behaving like this. It'll just be equal to x minus 4. So it's not going to change. If it's equal to 5, okay, this absolute value will just behave like x minus 4. 5 minus 4 is 1. 5 minus 4 absolute value is 1. Now, if it's less than 4, we end up with a negative inside the absolute value. So what will the absolute value do? It will flip it. It will change it from negative to positive. Well, how do I change a negative to positive? Well, I take that original x minus 4. Just doing blue. I'm going to take the original x minus 4, and I need to make it its opposite. Okay, so it's going to be a negative. So I'm just going to make a note here. The negative changes to opposite. Opposite. Therefore, it changes to positive. Okay, so we go from an inside negative to inside positive with that when we have that negative, when we apply that negative. So some people like to write it slightly differently, and they just do this. They just do negative x plus 4. So let's just check this. So if x is equal to 3, we will end up with 3 minus 4 is negative 1. Absolute value equals 1. Well, it will be the same as 4 minus 3, which is positive 1. Okay, so it keeps everything positive if we keep this domain. So this is what we call a piecewise function. Okay, for different domains, okay, this is gonna have two different domains, and it will behave differently for those two different domains. The big idea, though, this is a key idea. The domain boundaries are determined by where it's equal to 0. So that's the big idea. If we can determine where the boundaries are, this is the biggest part of this. We're able to determine where our boundary of our domain is, and then we can decide whether it's behaving normally or if it's going to be its opposite. Okay, and we show the opposite with that negative in front. So let's try, and there's a little bit of notation as well, but let's try this next one. Let's just keep with, I'll show you, we'll be more formal with the notation later. So again, we need to determine where the inside is positive, and we need to determine where the inside is negative. Okay? And if you recall, at the very beginning of this lesson, we talked about the idea of going backwards through the absolute value. And that's why we get two possibilities, because this is really finding x. Okay? And we need to account for two possibilities, where it was positive going into the absolute value or where it's negative going into the absolute value. So this is how it shows up now algebraically when we talk about these piecewise functions. So where's the boundary then? Okay, so that's the key part. The boundary here, okay, so I'm just going to write it down here. The boundary is where it's equal to 0 is going to be when x equals 12. That's my boundary. So then I'm going to use that boundary to establish my domain. So where it's equal to positive, here, it's going to be where x is less than or equal to 12. Okay, because if it's bigger than 12, it's going to give me a negative inside. So I want less than. So the opposite then is true here. We want, when is x going to be negative? Well, if x is bigger than 12, for example 13, 12 minus 13 gives us our negative. Once we've established the domain, I know that this equation is equal to, it's just going to stay the same for the positive, and if it's negative, we have to flip it. And I'm just going to rewrite it as x minus 12. So it's going to behave like 12 minus x. If x is, as long as x is small enough, it's just going to stay positive. Nothing's going to change. If once x gets too big, we're going to have a negative, so we're going to have to flip it. So we have to use the opposite, which is x minus 12. So there it is. So we can, this is the key then. We need to find the boundary. The boundary really is the key.